next talk, and our next speaker is Jared, and Jared's going to be talking about Gateway. So I'm super excited about this thing, but I'll let him tell us everything about Gateway. Welcome.
Thank you. Thanks for having me. Let me just share my screen here. Let me know if you can see it. Hopefully you can see it. But yeah. Hi everyone. Thanks for having me. It's great to be here. My name is Jared, and just a little bit about myself. So I've been at Compound for about 2.5 years. Pretty much starting work, designing and working on the V2 protocol, which is we now know as the Compound protocol. And today I want to talk about Gateway. So Gateway is Compound's blockchain project that we started last year. And yeah, just hoping to sort of explain what it is, why we're building it, and give you a little bit deeper understanding maybe how it works and sort of what like the current status is and things like that. So yeah, jumping right in. I guess the why are we building Gateway? What's the motivation for Gateway? In my mind, there's always been like two kind of a confluence of two reasons that we're sort of building Gateway. One is sort of like the V3 version of the Compound protocol, and going back a little bit to sort of last summer, at the end of last summer. So at the beginning of last summer, we began distributing our governance token on Ethereum, and we experienced like the summer of DeFi and what that explosion was like, and there was a real feeling of product market fit. The protocol went from like growing sort of 10x per year to growing like 100x per year. So like basically from like moving from like 20 million in assets to 200 million in assets in year one of its life, the protocol, and then like from like 200 to 20 billion, sort of beginning with last summer. And I think what became pretty clear, at least, but if it wasn't already clear, was that Ethereum was kind of like unusable for the average person at that time. Like gas costs were getting extremely volatile and mostly just expensive, and still are. The network was congested, and we had started to think about like scaling, how to scale Compound beyond the boundaries of Ethereum and sort of reach like a broader set of users, and so that part of Gateway is certainly thinking about how to scale Compound and not like be constrained by the underlying network. At that time, we sort of took a look around at the next generation of blockchains, L1s, L2s, sidechains, rollups, all things, and like what became clear and it was that it was still going to take some time to see how things would actually play out, but we knew that we wanted to build a V3 that sort of would work for users no matter like which technologies that they were experimenting with, and we sort of concluded that having a chain would like ultimately let the Compound governance have like more control over the economics of the protocol, and also would be a way to keep fees low in the long term. And there was this promise of Polkadot, which was that with Substrate you could build a chain which was targeted to either run as like a standalone chain or as a parachain. And the idea with this constrained parachain is that it's more constrained, but you don't have to worry about the security of the validators. You're sharing the securities with the other parachain. You're sharing the security of the relay chain with the other parachain, and the validators and the consensus layer are shared. And so you really need to only worry about the availability of being able to process transactions and not and having servers available to process transactions, and not whether they're executing things faithfully or reliably. The problem was that, like, yeah, I mean, I guess Polkadot was kind of has still yet to launch parachains on mainnet, and like this whole time we've been working on Gateway. It is has been in active development itself, but we also the idea was to sort of take the lessons from the past 2.5 years, get rid of the constraint coming from the underlying network, and build a protocol that was sort of streamlined and to focus on like our specific application, or what we consider it to be. And I guess for continuing on that, like the other part of why we're building Gateway is, in my mind, is this cash token, which I think these adjectives are pretty descriptive, so I'll just unpack them. So portable, it exists on many different chains, and can be transferred between them. It's a little bit special as far as assets on Gateway is concerned. I'll talk a little bit more about that later. But one way in which it's special is it's interest bearing, and it's also a unit of account. And so combining these things, the V3 protocol, it's cash token. So the hope was really to just focus on building out certain application layer and leverage a blockchain framework to help us deliver that. In reality, I think we spent a lot of time dealing with the idiosyncrasies of the framework that we're using, and sort of re-architecting things a bit. But this is kind of the original thinking behind things. And yeah, I guess moving ahead, we can get back into some of that discussion later. But so what does the architecture for Gateway actually look like? Starting with maybe like more of like an end user point of view. Like so the vision for Gateway is actually fairly simple. In this simple diagram, you can see like the stars on these representations of like connected chains to Gateway. So you have a chain for Gateway, and then you have like other chains which are connected through their star ports. So in this example, like Ethereum and Tezos. And the idea is that the star ports are the main point of contact between Gateway and these other chains. There's something like a smart contract on each chain, and whatever the analogous concept is of a smart contract on that chain. And Gateway has like a superset of all the addresses which exist on all the connected chains. And so you could transfer between an Ethereum user and a Tezos user by maybe for example, you could upload ETH on Ethereum, so you lock Ethereum in the Ethereum star port. That emits an event and becomes part of Gateway. And now that the user on Ethereum can borrow, they could send the ETH to the Tezos address, but then they wouldn't be able to extract ETH to a Tezos address, because the ETH asset itself wouldn't exist on Tezos, and we don't have any kind of wrapping of assets at this time. So the easiest thing to do is like you can borrow cash against the ETH on Tezos. So from the user point of view, all they have to do is like lock the ETH, and then they can transfer cash, which automatically borrows against their ETH, which I'll talk a little bit more about in a second too. But from the Tezos point of view, you basically talk to Gateway and say, I want to extract this cash that I've received, and you get a notice that you take to Tezos that lets you actually pull the cash out of the Starport on the Tezos side. And there's a few, from like the architecture point of view, there's maybe a few things to note here. So first of all, there's a few protocol actions. It's pretty small surface area as far as the protocol is concerned. What's not shown here maybe is like there's also a mechanism to synchronize so because this cash token exists on these different chains, and because it's interest bearing, there's an interest rate, and there is a mechanism to synchronize the rates between the chains. But overall, pretty simple mechanisms. And then like once assets are inside Gateway or uploaded to the star ports, it becomes a lot like a typical smart contract on another chain, where things become a lot easier. You're sort of working with assets that are all in one place. Maybe the harder part, not shown here, is like how we ingest this data and emit these notices. But get a little bit more into that as well. Yeah, so like talking a little bit about what the surface area of the protocol looks like. So I mentioned there's only a few functions. There's the functions which exist are basically lock, so upload, lock, which is basically lock, transfer, extract, which is basically download, and liquidate. If you're familiar with the V2 protocol, these are very similar. What you'll notice though is that there's no borrowing and repaying, or supplying and withdrawing. Borrowing is actually now a state and not an action, and this is because of another improvement we made, which is to, instead of having two signed balances or two unsigned balances, which are the supply and borrow for a user, like in the V2 protocol, we don't even have the ability to represent sort of undesirable states anymore, where you're borrowing the same asset and resupplying it, which was never really is something that people do, but doesn't necessarily make sense for the protocol. So basically make those states now unrepresentable, and borrowing becomes a state where you have a negative balance instead of being a separate action with a separate balance associated with it. And yeah, I mean, it's kind of cool because you can do things just like upload ETH and then transfer, and when you try to transfer your balances, so you could upload ETH and then transfer cash, like in the previous example. And if your cash balance happens to go negative, that's fine as long as you have enough collateral to cover it. It's just automatically borrowing cash from the protocol. And by the way, cash is created by borrowing it from the protocol. I guess the other things to note here are that we also, as compared to the V2 protocol, sort of upgraded the risk engine. In the V2 protocol, there's collateral factors which apply to like one side of a balance equation on the collateral side. We're currently using now factors on both sides, so adjusting borrow balances by these calling them volatility factors now, and using them on both sides. But it's something to help with the idea is to help with the capital efficiency of the system, and representing risks more in a little bit finer grained way. But yeah, I mean, I guess the larger idea is with the gateway is also to be able to do things like upgrade the risk engine now completely, and do more sophisticated things that we weren't necessarily able to do inside the comptroller contract on Ethereum. But yeah, I mean, I guess the last thing to notice is that there's like a change to liquidation as compared to the V2 protocol. So in the V2 protocol, liquidators always repay debt, and then they basically repay, borrow, and then seize some collateral. In Gateway, liquidators can basically transfer debt, so they can assume the debt of the borrower without having to necessarily repay it. And this is kind of an improvement, and we introduced it because Gateway is a separate chain now, and having to repay or supply an asset before liquidating would be an extra step. And in general, we've always tried to keep the liquidation system in Compound, with pretty like quick turnaround, we think that speed is sort of a big advantage when it comes to liquidations. And so removing the requirement to upload collateral first in order to be able to liquidate somebody sort of opens up the set of possible liquidators that can perform the liquidation, and doesn't really hurt the protocol. So it's kind of a nice feature, I think, of Gateway, that we changed liquidations in this way. Talking about cash a little bit more. So I mentioned that it was portable and interest bearing. Portability, as I said, it comes from the fact that it really exists on every chain that Gateway is connected to. It is interest bearing. So all cash in Gateway, all interest in Gateway is paid in cash, or is earned in cash. And actually, it's done. Getting a little into the weeds, but unlike V2, it's cash is sort of accumulated linearly by the markets in the asset markets, and then sort of all compounding kind of happens in cash itself. Also, compounding now happens over time instead of over blocks, which is a slight difference from V2. But it kind of it's just to think about what that means a little bit. It's kind of nice for something like an NFT market, or something where you can't necessarily pay interest in the underlying, because you can't, maybe there's only one token which constitutes the underlying. But you always have an asset which you can pay and earn interest in. Just a little about cash, and then starting to get into more of zooming in on the architecture and some of the different components in the system, and how they start to fit together. And we'll sort of zoom in on how these fit together more as we go here. But from the high level, 10,000 feet, there's really just a few entities, so maybe like 3 layers and like 4 entities. So like the runtime layer, which is sort of the state of Gateway, which is basically the state of the chain, and it's what gets executed on in Substrate, which is the framework we're using for building the blockchain. It's really the authoritative state of the chain. And then we have the oracle layer, which you can think is composed of both these oracles and archivists, which the archivists just make. It's like the archivist has an untrusted role, which the oracles are. Starting with the oracles are really the trusted role. They have keys, which in aggregate can be used to sign data going either to the runtime or to the star ports. So either events coming from the star ports to the runtime, they can sign the block metadata and the events, and those are persisted by the archivist and made available to the runtime. And vice versa for signing notices coming from the runtime, which are then posted to the star ports. So like very high level view of what the information flow in between these high level components in Gateway looks like. Zooming in a little bit, you start to see like more exactly what the interfaces between some of these components are. I think this is actually a fairly precise diagram, so you can get a pretty good idea of really how information moves in Gateway looking at it. But so runtime also has things like prices, and it can accept requests coming from end users, and the oracles fetch notices from the runtime by a number. There's a lot more details to get into here, but essentially this is the things that can be done in Gateway. And then zooming in even more to sort of like the exact or like the implementation in Substrate. So Substrate is organized around these modules called palettes. Palettes are sort of individual modules within a substrate blockchain, which can have associated state and events and errors and extrinsics, which they call them, which are basically functions you can call. And the first, so what this is, first column is showing like which functions are in which palette. And so there's like a gov palette, which has essentially like a pseudo function, which people can propose and vote to call other functions in the chain, basically through the gov palette. Then most of the functionality is in the cache palette. Actually, in the first version of Gateway, all functionality was in the cache palette, and then over the summer we started to re-architect things, mainly to separate to deal with some security concerns we had, and separating the functionality of the oracles and really isolating them, and also being able to more well define these boundaries between pieces of the system. So we had, as I was saying, we had everything in the cache palette, and things were pretty tightly coupled, and it was getting already pretty hard to make changes. So another goal besides the security of separating oracles of the refactoring was to make the dependency graph clear and not have things depending back into substrate, and have these clean boundaries between things. But yeah, I think what you can see from this diagram is, well, what you can do in cache. So it has the ability to ingest blocks and execute requests coming from the users. The users can do things like extract, liquidate, and transfer to get a sense of what the notices are. The extract notices are what's brought to the starport in order to actually extract assets from Gateway. We give support the ability to change supply caps on the starports, because Gateway has supply caps, which are implemented both at the starport and in the Gateway runtime. And then change future yield as part of that interest rate syncing mechanism I was talking about. Also the ability to change oracles, the set of oracles happens through the runtime. And finally, the ability to add and upgrade a starport. So there's a function to add a starport, and then there's also a notice to support upgrading them once they're added. And then finally, I guess we have there's another palette, which is the prices palette, which supports posting prices using the open oracle format that Compound had previously defined, which the V2 protocol was previously using, but not exactly using anymore. So yeah, hopefully that gives you a better idea of maybe the implementation of things. And there's obviously a lot more that could be said about that too, but it's moving ahead quickly. I think so. Like, I guess the roadmap and as far as the timeline are concerned. So, obviously the Gateway is an ambitious and challenging project. We knew that much coming into it. I think we still believe it's like what we believe in the future of DeFi for sure. And like, I think, most of the innovation that is going to happen in this space is still yet to come. And the goal is really to build a robust platform, like a long-term foundation that's like economically reliable, and which Compound and governance and the community can build upon, as like a real engine of like growth for innovation to happen on. And so what I can say about the roadmap is like we're basically safety first. We're not rushing the QA process. We've already as I was saying, over the summer took a few steps back to re-architect some things and get more comfortable with security profile, and we'll continue doing that. Obviously, I think the products and the features are quite well defined, but we're in this process now of implementing things really carefully, and I'm not prepared to put a date on when we'll be done with that process, but it will continue making steady progress on it. I guess the other thing to mention is that Gateway is not the only thing that we're working on at Compound, so we do have a lot of other exciting projects. I guess it's a good problem to have, but fortunately, many things, some of those projects are growing more rapidly than we anticipated, and we're still a small team. So if Gateway is interesting to you, or other things that Compound works on are interesting to you, especially we're hiring engineers. We're also hiring in other parts of the company. So please get in touch if you're interested in learning more about that. And yeah, I guess the other thing to maybe mention and keep in mind about the roadmap is Hofstadter's law has certainly come into play, and probably continue to come into play. And I guess if you're not familiar with that, it's basically the recursive law that says that things always take longer than you think they're going to take, especially when you take into account Hofstadter's law. I guess finally, I'm sure, I think a lot of information moved pretty quickly. If you have any questions about Gateway or about anything else related to Compound, you can always find me and others in the Discord, and also on the forum on comp.xyz. Or also I'm on Twitter. If I can be helpful for anything, feel free to reach out. But yeah, happy to answer any questions. I think we're about out of time, so I'll wrap up here. Thanks, everyone.
Thank you so much, Jared. And that was a really good and deep overview of how everything is structured and is working on Gateway. We are out of time, but I'll ask one question just before we move on to our last talk. How does composability work in this world? And what does that look like? And how should people think about that?
Yeah, great question. I think, a lot of it is still unknown. Like, a lot of it remains to be seen. But one of the ideas with Cash Token as well was to be for that to be one of the composable pieces. And we can think about Cash Token as like maybe the tip of V3, and so like Cash Token itself can be like embedded inside, so it's part of V3, but it can be embedded, for instance, inside of like V2 as like a Z token, or there could be a market. So there's lots of interesting things you can do with the Cash Token. There is the ability also to initiate TRX, what we call TRX requests, which are sort of the requests that users can initiate. They can send them either directly to Gateway, or they can submit them through the Starport and have them, through a contract or something, and have them executed on Gateway chain. So we think there's a lot of interesting things to do. There are, unlike the V2 protocol and everything happening on Ethereum, it is a little bit trickier, right? Like, some certain things are asynchronous, and so it's not totally clear how it might affect like certain design patterns for composability that exist today. But we've tried to create opportunities for composability.
Absolutely. I think it's a very giant experiment, and just to some sense, because you have to sort of test it out and see how to evolve. So it's very exciting. Everybody who found this interesting, obviously you can check out the links Jared posted on how to see more about what's happening with Gateway. And thanks again for the presentation.
Thanks, Karthik. Great to be here. Look forward to the rest of the conference.